Hello everyone, welcome back to MacroLearning. We're in the alkanes part of organic chemistry. Alkanes part. And today the question is draw all the constitutional isomers of heptane. I'm sure you know what constitutional isomers mean, or you can say structural isomers, same thing. So what is heptane? It's a 7-carbon alkane, 7-carbon alkane. So the simplest isomer would be just the straight chain version, alright? So 1, 2, 3, 4, 5, 6, 7, 7-carbon chain, linear chain, that's N-heptane, okay? Now to make the other isomers, what we have to do is to, remove some carbons, like 1 carbon or more carbons. Use the removed carbon or methyl group or some larger group as the substituent, and then use the remaining chain as the main chain. For example, we'll remove this methyl group and we're left with a 6-member or 6-carbon chain, which is to be used as the main chain, and the removed methyl group will be put onto the main chain as substituents here or here, okay? But the thing is, when you really go about doing this, it's really easy to miss 1 or 2 or something, and it's also easy to have duplicates, So what I would do is take a sort of a systematic approach. Which is go 1 carbon at a time. So 1 carbon down a time, and use the substituents and the main chains to get all the combinations you can to make the other isomers. The other thing is, whenever you see that what you're doing is changing the main chain, whenever you figure out the main chain is being changed because of the substituents, then stop, period, right? Do not consider that a isomer. It is an isomer, but the thing is that it's going to be a duplicate of something you come up with later. It's going to be a duplicate, so that's why we do not include it for the time being, to avoid duplicate or to avoid duplications. So I'll show you what I mean. Let's see. So that's 1 isomer, and what I'll do is take off 1 carbon from it. Let's just put it here. Whoops. And we're left with 6 carbon main chain. Okay, and we are left with 1 carbon substituent, and that's only going to be a methyl group, nothing more than that. So where can we put the methyl group? We can put it here. That's isomer number 2. Okay, or same main chain, methyl group in here instead. Okay, that's the 3rd isomer that we have come up with. If you wonder why couldn't be here, would that be another isomer? No, it's not, because that would be the same isomer as this. Okay, or can you put it here? Would that make it another isomer? No, because that would be the same isomer as the 2nd isomer. Because of the symmetrical structure of the chain, there are only 2 possibilities to put a methyl group onto a 6-carbon main chain. Okay, so that's pretty much it for removing 1 methyl to be used as substituent onto the remaining main chain. And next step, remember, 1 carbon down at a time. Okay, so this time we take off 2 carbons from the structure, and we're left with a 5 carbon main chain and a 2-carbon structure to be used as the substituent. So it could be 2 methyl groups or it could be 1 ethyl group. Is that right? Okay, so for 2 methyl groups, let's see what are the combination, what are all the possibilities. So we take the main chain. Let's do it on this one first. Main chain, 5-carbon chain, 2 methyl groups. It could be one on this carbon and one here. So that's another isomer, no problem. We're not changing the length, we're not changing the main chain, right? Remember what I said in the beginning? Whenever you see that the main chain is being changed, then you have to stop. I'll show you how that works later. Or the 2 methyl groups can be both on this carbon, right? Right, yeah, that's another isomer. Or could it be one on this carbon and one on this carbon? Yep, that's a 6th isomer. So have we exhausted all the possibilities for 2 methyl groups onto a 5-carbon chain? Have we exhausted all the possibilities? I think there's one more where both methyl groups go onto the middle carbon, right? Now we have exhausted all the possibilities, I believe. So that's it for 2 methyl groups onto 5-carbon chain. But remember, there's another possibility where we can have 1 ethyl group instead of 2 methyl groups. Still a 5-carbon chain. Excuse me. So with the ethyl group, what we can do is we can put the group on the middle carbon like that. And is that it? Are there any other possibilities? Can we put it onto another carbon like that? Okay, let's see. Here you're changing the main chain like I discussed earlier, right? Now the main chain is going to be this 6-carbon chain. It's no longer this yellow chain, it's this chain here. So oops, I missed 1 carbon, but anyway, you get my idea. So this is where you stop. This is where you do not, consider this as a isomer, because it's 100% that it's going to be a duplicate of something you draw out later. So you don't include this one, period. Okay, so let me just wipe this out. Because of that, we have exhausted all the possibilities of 1 ethyl group onto 5-carbon main chain. Okay, so, or 1 carbon down at a time. Now we are at removing 3 carbons and be left with the 4-carbon main chain. And so what are the possibilities? 3 carbons to be used as substituents. That could be 3 methyl groups straight, right? So we can put the 3 methyl groups, 2 on this carbon and 1 on this carbon, and I believe that's it for 3 methyl groups onto a 4-carbon main chain without changing the main chain. So, and that's the 9th. Is that the 9th isomer we have? Yes, the 9th isomer. We have 9 structural isomers by now. And let's see, are there any other possibilities? So 4-carbon main chain, right? 3 carbons that we have that can be used as substituents. So could that be 1 methyl plus 1 ethyl? right? Three carbons. That could be 3 methyls, like here, or it could be 1 ethyl plus 1 methyl. So let's see, is that possible? Does that make any new isomer? So 1 methyl would have to go here, and the ethyl, if we put it here. Now what's happening is, again, it's changing the main chain. Now the main chain is this. It's no longer this 4 carbon chain. It's now 5 carbon yellow plus red chain. So it's not it is an isomer, but I am sure it's duplicate of one of the other ones. Alright, so you just simply do not include this one, period. Or if the ethyl goes onto this carbon, same thing. It's making the main chain longer. Now the main chain, imagine, why do I mention main chain over and over? Imagine you are trying to name the compound. You know, you have to pick the main chain. Now what's the main chain? It's not the 4 carbon chain. It's this chain right here. So its main chain is being changed. And also, this is not a isomer that we want to include either. It's a duplicate of one of the other ones. So this simply does not exist. And I think we have, well, we can try one more. I mean, 1 carbon down at a time. Now we can try taking off 4 carbons. And we're left with 3 carbon main chain. Let's see if that's possible. 3 carbon main chain plus 4 carbons to be used as substituents. The 4 carbons could be, it's not going to be 4 methyl groups. It's not possible, right? We can put a maximum of 2 substituents here. It's not, we can't have 4 methyl groups. It's not gonna make a right structure. So it could only be 1 ethyl plus another ethyl, right? Only possibility, I think, is like that. But you'll see it's changing the main chain again. The main chain is way off this time. It's this red line, the 5 carbon chain. That's the main chain now. So the main chain is way different, and it's because of that it's a duplicate of one of the other structures that you had before. So again, we're not considering this one, and that's it. We can't go any fewer carbon from here. We're stopping right here, and we're sure that we've got all the possibilities. We didn't miss anything, and in the meantime we're not having any duplications. Okay, so a total of 9 isomers for heptane, and we have all of them. And I hope you got my idea and my trick about avoiding the duplications, and at the same time making sure we have everything. Okay, thank you very much. See you next time.